Thank you very much. So today being the 6th of December, 2024, we shall proceed with tutorial questions that are specially made for lesson 2. And the topic reads as the samples, sampling distribution, and confidence intervals. So in this tutorial set of questions, we have 38 questions, out of which, like I mentioned before, 20 are conceptual problems, and the remaining are calculation-based or computational problems. So I don't know how we're going to promote this, but let's start. Maybe if we have the opportunity, we can solve more than 10, but let's assume we are solving close to 10. So with that, we may start with multiples of 4. So with multiples of 4, we should be able to solve 9 questions. And if we pick question 38 as an additional problem, then we're going to have 40 questions, 10 questions altogether. So to start with multiples of 4, all right, the question in there says, what does the central limit theorem guarantee as sample size increases? What does, that's question 4. What does the central limit theorem guarantee as sample size increases? A, the population mean will increase. B, the sampling distribution of the mean will approach normality. C, the sample mean will always equal the population mean. D, variance of the population will decrease. Can you unmute yourself and answer this question? What is the right option? What is the right option? Question 4. What does the central limit theorem guarantee as sample size increases? You need to unmute yourself before you speak.
The answer is B.
B, sir.
The answer is B. The sampling distribution of the mean will approach what? Normality, right? Exactly. You know, central limit theorem let us know if the sample size is sufficiently large, then the sample distribution of the mean will approach what? Will approach normality. Excellent. So you can go to problem 8. Problem 8 says, question 8, it says, what happens to the margin of error when the sample size increases? Look at this. What happens to the margin of error when the sample size increases? A, it increases. B, it remains unchanged. C, it decreases. D, it becomes 0. Unmute yourself and answer this question, and you should be able to convince yourself of the answer. Yeah. Margin of error when the sample size increases.
It decreases. C.
It does what?
It decreases.
It decreases.
It decreases. Okay. And why is that so? Why will it decrease and not increase? The margin of error, you remember the standard error of the mean. It is given by which formula? Standard deviation divided by the square root of n. Do you remember this? So if this denominator is increasing and your standard deviation remain the same, or maybe it is changing, but it cannot catch up with how large your sample size is, so this ratio will definitely decrease. We do what? We decrease. So as the sample size is decreasing, the margin of error, as the sample size is increasing, the margin of error is what? Is decreasing. And in fact, this type of relationship, they call it inverse relationship. When one is increasing, the other is decreasing. And when one is decreasing, the other is what? Increasing. All right? Thank you. So we can go to the next problem, and that is problem 12. Problem 12 says, a researcher takes 50 samples of size 30 from a population. If the population mean is what? Is 60, and the standard deviation is 15, what is the mean of the sampling distribution? A researcher takes 50 samples. Remember? Central limit theorem. The researcher takes 50 samples of size sufficiently large, because the size is what? 30. N is sufficiently large. Okay? And then we have number of samples, 50. If the population mean is what? 60, that is mu equals to 60. And the standard deviation of the population is what? Is 15. What is now the what? The mean of the sample distribution. The mean of the sample distribution, which we call the expected value if I'm not mistaken, according to the central limit theorem, the mean of the sample distribution S will do what? Will be approximately equals to the mean of the population. You remember that? The expected value will be approximately equals to the mean of the population, provided what? You have sufficiently large sample size. So central limit theorem guarantees this, that this the mean, which is a, let me erase this, which is a X bar, okay, which is X bar, will be approximately equals to the mean of the population. So the right option there should be 60, and that is option A. No calculation, just your knowledge of the conceptual understanding. Okay, central limit theorem guarantees that when a sample size is sufficiently large and you've taken enough samples, then the expected value of the mean, which is the mean of the distribution, is approximately equal to the mean of the population. Okay, we can go to the next problem, and that is problem 16. Problem 16 says sampling bias occurs when dash. Sampling what? Bias occurs when A sample is too large. B, randomization is used in sampling. C, some members of the population are systematically excluded. D, the sample standard deviation is unknown. What is the right option here? Unmute yourself and speak out the answer.
The answer is C.
The answer is E. Some members of the population are systematically excluded. That is correct. The answer is C. Okay? When a sample size is too large, then the standard error will reduce. Okay? So randomization, that one will even increase what? Accuracy. The sample standard deviation is not even connected to the bias in this case. Let's go to the next problem, which is problem 20, right? Problem 20 says, a researcher uses systematic sampling to survey students. Remember, systematic sampling procedure. Okay? What might introduce the bias in this method? First and foremost, you remember the sampling, which we call systematic sampling. Like, for instance, you can arrange your population and start picking odd numbers or even numbers or multiples of 4, as we are doing now. This is systematic sampling. Out of 38 problems, we are picking multiples of what? Of 4. So in the end, we are going to pick 9 questions. So that's a systematic sampling. We can start to pick multiples of 5. We are being systematic in what we choose. Whatever question that falls under the multiples of 4, we solve it. Okay? So now, let's carry the knowledge back to sampling procedure. So when you now use systematic sampling procedure to survey students, what might introduce bias in this method? A, using a small sample size. B, a pattern in the population that coincides with the sampling interval. C, not knowing the population standard deviation. And D, using random number generators. What do you think is the option A?
A, sir.
The answer is A. Okay, let's keep it. Somebody say A. Any contrary opinion?
B, sir.
Somebody say B. Any contrary opinion?
D, sir.
D. Somebody
Yeah.
say D. Amazing. So do we have anybody say C? Nobody's going for C. So we have 3 options. Okay, let us take them one after the other. Remember what I just explained about systematic what? Sampling. Somebody now say A, using a small sample size. Using a small sample size, how will it increase or how will it introduce your bias? Okay, maybe that could happen, right? If your sample size is small, maybe you can introduce some bias. However, we are talking about systematic sampling procedure here. Whatever thing we get, whatever method we use for sampling, provided the sample size is small, the bias is the same for every other method. If you like to use randomization, complete randomization. If you like to use systematic, if you like to cluster, if you like to use what? Simple random sampling. So far your sample size is small, that error is present for everyone. But we are talking about an error that is peculiar to systematic sampling here, in which if you look at that, A will not be the correct answer. Somebody also used D, using random numbers generator. In fact, this will even increase the accuracy. When you use random numbers generator, by the way, by the time you use random number generator, it is no longer systematic. It becomes simple random sampling. Remember this. Take notes. White B, which is the probable answer, a pattern in the population that coincides with the what? Sampling interval. I just give an example of multiples of 4 here. Suppose these are students and not what? And not questions. We will be picking 4, 8, 12, 16, 20, 24, 28, 32, right? 36. Okay, these are the people we are going to select. Now, suppose that there is a pattern in the what? In the population that coincides with this numbering. That is, the 4th student is a poor student. The 8th student is a poor student. The 12th student is a poor until you get to 36. This poor in performance will affect the whole data generation. So that is what they are saying in B. A pattern in the population that coincides with the sampling what? Interval. You will not be able to get the representative or the representativeness of your population again, because a pattern is repeated exactly at the point that you are using the systematic sampling. So the right option is option B. I hope this is clear to everybody. Okay? Perfect. So we go to problem number 24. Problem 24 says, what increases the precision of a confidence interval? What increases the what? The precision of a confidence interval. A, decreasing sample size. B, using a lower confidence level. C, reducing variability in the population. D, increasing the sample mean. What increases the precision of confidence interval?
The answer is D.
You say
C,
what?
sir.
So we have the first option to be what? A. Somebody said A. And then somebody said what? C. Any other contrary opinion? Any contrary opinion? So what is B saying? Using a lower confidence level. What increases the precision of confidence what? Interval. Do you remember confidence interval? Do you remember confidence interval? CI? Confidence interval around the mean. It could be what? X bar plus or minus T. Okay? Multiply by what? Standard deviation over the square root of n. If you remember this in your notes, this is where you don't know the population. You don't know the population standard deviation. Okay? Is that formula correct?
Yes, sir.
Okay. So now, if you don't want to increase the precision of the confidence interval. You want to be precise. Which of this option, look at it again, which of this option is going to give you what you need? Somebody said A. This is what? Decreasing the sample size. Okay, sorry. That's question 24, yeah. A says decreasing the what? The sample size. Once you decrease the sample size, what happens to this formula? Once you increase the sample size, what happens to this formula? Huh? Do you get my question? Look, by the time you decrease the sample size from here, the standard deviation divided by the square root of n, it can be big, of course. And once it is big, that means we are going to have a higher what? Confidence interval. You see it now. Once this is big, you know, you'll be subtracting a bigger number from the mean. So you are not going to increase precision. Rather, you are going to do what? Widen the margin. You know, confidence interval is from here to here. By the time, let's say, from x bar minus t, okay, standard deviation divided by n to x bar plus t, standard deviation divided by root n. If you decrease n, if you make n smaller, if you make n smaller, if you make n smaller, this quantity ts over the square root of n is going to be, oops, this is going to big if you make n small. Remember the relationship we talked about initially. If you make n small, this relationship will become big. And once this is big, multiply by t, again, it's going to be big. All right? So you'll be removing a big number from n. It will be a very small number. And then you'll be adding a big number to n, to x bar. It is going to be a very big number. So the margin will become wide, not narrow. So in this case, you will not be increasing the precision. Rather, you'll be decreasing it. But there'll be too wide margin before you can get your, where you can say the mean can fall. So this is not, or it cannot be the option. But again, let's now see whether option C could be an appropriate answer. Option C says reducing variability in the population. Remember, reducing what? Variability in the population. Variability is what? The standard deviation, the variance, okay? So if you reduce variability, this is interesting. If you reduce variability, what happens? This quantity, s over the square root of n. Now answer this question. Is it going to be small or big? Small or what? Or big? Tell me. When you reduce variability, this quantity, is it going to be small or big?
Hello, sir. It's going to be small.
It is going to be small. Excellent. So that means you will be adding a small number to x bar, and then you'll be removing a small number from x bar. You see it now. So you are going to increase your precision. So this thing, instead of being wide now, is now going to be, let's pick a different color, is now going to be small. You see this? It's going to be small. Okay? So So if you want to increase precision, you need to reduce variability. This is good. Let's go to question number 28, right? This is the next one. All right. Question what? 28. Are you okay? So what does it say? It says a population has a mean of 70 and a standard deviation of what? 15. A population has a mean, population mean, okay, not sample mean. And a standard deviation of what? Of 15. Okay, equals to what? 15. Take note of this, not sample population. For now, yeah, we have a sample. For a sample size of what? 36, n equals to 36. What is the expected mean of the sample distribution? What is the expected what? Mean of the sample distribution. All right? Again, you're not going to make any computation here. Rather, you are going to evoke an application of what? Central limit theorem. What you just need to do is to check whether this particular data given to you satisfies central limit theorem or not. Central limit theorem says that whenever you have sufficiently large sample, the expected value of the mean or the mean of the sample will be approximately equals to the mean of the population. You can see questions like this in the exam will look somehow. Maybe you want to do calculation, but it is just look and say, the sample size is sufficiently large, yes or no? The answer is what? Yes. So that means we can use central limit theorem. Whenever we have sufficiently large sample, the sample of the distribution of the mean, which is the expected value of the mean, will be approximately equals to the sample of the what? Of the mean of the population. So the mean we are looking for is actually equals to the mean of the population. The expected value equals to what? Equals to 70, which is the mean of the what? Of the population. No calculation here. Perfect. So the next problem is problem 32. Okay. Question number 32. It says, a researcher calculates a sample mean of what? 50. Now a sample mean, X bar equals to 50. And a standard deviation of 5, S equals to 5. For a sample size, N equals to 25. What is 95% confidence interval? You are given the Z score to be 1.96. Z is what? 1.96. All right. So you can use the formula. Confidence interval, the 95% is what? X bar plus or minus T or Z S over the square root of what? N. This is what you need. So you just need to calculate this quantity. Z multiplied by S over the square root of what? N. Your Z is given to you as 1.96. 1.96. Even this is supposed to be T value instead of Z, but it's okay. Multiplied by S, the standard deviation is 5. Divided by the square root of N is what? 25. So this is 1.96 multiplied by 5 over the square root of 25 is 5. Okay? This is 1.96 multiplied by 5 divided by 5 is 1. So this is 1.96. So this quantity, Z, S over the square root of N is what? 1.96. So you now go back to your confidence interval. CI is what? X bar, which is given as 50, 50 plus or minus 1.96. This means it's equals to 50 minus 1.96, 50 plus 1.96. Are you okay? So you can subtract. What is 50 minus 1.96? Tell me the answer. Those with the calculator. 50 minus 1.96. Are we good? What is the answer? Press your calculator. Here I got 48.04, comma. Then 50 plus 1.96. We have this to be 51.96. Okay? So CI confidence interval, it ranges from the minimum value, 48.04, up to the maximum value, 51.96. Is there a correct option there? Yeah. So the correct option is what? Is option A. Are we good? Please look at this very well. If there's any question, let me know. Otherwise, we proceed. Okay? Any question? Is it good?
It's good, sir.
Excellent. So we can go to the next problem. And I think that is the last problem, except you pick contact 8. And that is problem number 36. Okay?
I don't like the
Are we good? Yeah. Our moderator, remember to do your job. Problem 36 says, in a sample size of 16, n equals to 16, with a sample mean of 60, x bar equals to 60, and a standard deviation of 10, s equals to 10. Calculate the 90% confidence interval given the t value. You know I said the last time, that's z, supposed to be t value. Given the t value to be 1.753. Because usually when you are dealing with population, that's when you use the z-score. But when you are dealing with the sample, you talk about the t value. Okay, the t-score. So now we want to find the 90% confidence interval. The same formula, x bar plus or minus t instead of z, s divided by the square root of n. Okay, so that means we need to calculate this quantity. Let me bring it out and do the calculation. T s over the square root of n equals to, our t is 1.753 multiplied by s. Your s is given to be 10 divided by the square root of n. N is what? 16. So this is 1.753 multiplied by 10 over the square root of 16 is what? Is 4. Is that good? 1.753 multiplied by 5 over 2. All right? And this is equals to 1.753 times 5 divided by 2. Okay? So what is 1.753? 1.753 multiplied by 5. Okay? That gives 8.765 divided by 2. Okay? And when you divide this by 2, please always cross-check. That could be error. When you divide by 2, you have 4.38. Maybe I want to stop at 2 decimal places. So t s over the square root of n is what? 4.38. So I can go back to my formula. I can do what? Go back to my formula that says CI equals to x bar plus or minus t s over the square root of n. So this is x bar is 70, if I'm not mistaken. Let me confirm that. X bar is 60, not 70. X bar is what? 60. Clean this. X bar is what? 60 plus or minus ts over the square root of n. We got that to be 4.38. Okay? That means our confidence interval is 60 minus 4.38, comma, 60 plus 4.38. Okay? So what is 60 minus 4.38? 60 minus 4.38.
55.62, sir.
Excellent. 55.62.
0.62.
Excellent. Then 60 plus 4.38, we have 64. Okay, point what? 38. So the
38,
CI,
yes.
excellent. So the CI is actually equals to this. Is there any right answer? Oh, good. This one too, the correct option is what? Option A.
Option
Is
A.
that correct?
Yes, sir.
Excellent. So let us pick one more. That is an additional problem, question 38.
Mm.
So question 38, which is almost the same pattern, the same procedure, the same idea. A sample of 10 has a mean of 85. A sample of 10, n equals to 10, x bar equals to what? 85. And a standard deviation of 10, s equals to 10. Calculate the 99% confidence interval given that the t value equals to 3.250. Okay? 95% confidence interval CI. Okay. CI equals to, same formula, x bar plus or minus TS over the square root of n. Like I mentioned in the exam, we are going to provide, or in the test, we are going to provide this formula for you. You don't need to memorize it. What you just need to do is to be able to apply it when you see a question related to it. Okay? So we need to calculate the quantity T as the square root of n. Substitute what you have. Our T is a 3.250. Our moderator, please. Multiply by S, 10 over the square root of n. N is also 10. Okay? 3.250 multiplied by the square root of 10. Look at what I've done. Let us do simple algebra here. Moderator, can you mute those people, please? Let us do simple algebra here. Let us just learn this now. Look, 10 divided by the square root of 10 is equals to the square root of 10. The question is why? The question is why? So, how do I get this? 10 divided by the square root of 10, we can say is the same thing as 10 divided by the square root of 10 multiplied by the square root of 10 divided by the square root of 10. You know, the square root of 10 divided by the square root of 10 is 1. Any number divided by itself is 1. I said, look, what we have is this. The square root of 10 over the square root, 10 over the square root of 10. 10 divided by what? The square root of 10. I now wrote that this is equals to this. So 10 over the square root of 10 is equals to the square root of 10. I wrote why. I tried to explain. So what I did was to multiply the numerator and the denominator by the square root of 10. This is what we call rationalization. We call this rationalization. So I try to rationalize the denominator, where you will use the denominator to multiply both numerator and denominator. You know, any number divided by itself is 1.
Yes.
Any number divided by itself is equal to what? 1. Provided A is not equal to what? 0. 2 divided by 2 is 1. 3 divided by 3 is 1. The square root of 10 divided by the square root of 10, it is 1. So multiplying 1 by any number is still the same. You are not doing anything different. So that is the idea behind what we call rationalization. So the square root of 10 divided by the square root of 10 equals to the square root of 10 divided by the square root of 10 multiply the square root of 10 divided by the square root of 10. So 10 multiplied by the square root of 10, we give you this. We give you this. And then the square root of 10 times the square root of 10. This is the square root of 100. Okay? So 10, the square root of 10, you have it. The square root of 100 is 10. 10 cancel 10. Then you'll be left with what? The square root of 10. So 10 divided by the square root of 10 equals to the square root of 10. So that idea is what we use here. So I now brought it to continue our work. T S divided by the square root of n equals to 3.25 multiplied by the square root of 10. When you press the calculator, the square root of 10 is a 3.1623. And the next thing is now for you to multiply. Find the product. 3.25 multiplied by 3.1623. Okay? And that gives 10.28.
27. Okay, it's 28.
That gives 10.28. So it is S over the square root of n. So you can then go back to your confidence interval CI. CI is the mean. Okay, is what the mean, and the mean is what? 85. 85 plus or minus t multiplied by s over the square root of n, which is 10.28. Okay, so that means our CI is 85 minus 10.28, comma 85 plus 10.28. Okay, so what is 85 minus 10.28? 85 minus 10.28. 10.28. What do you get from your end? I got here 74.72. Is that correct?
Yes, that is correct, sir.
Then 85 plus 10.28. That will give me what? 95.28. Is that correct?
28. Yes, it's correct, sir.
95.28. Okay. So the right option is not there.
D.
Yeah, it's not D. There is something missing in D. Look at the upper part. It is 94.28. So this is supposed to be 95.8. Yeah, maybe that is a typing error. But the right option is actually D. Yeah, typing error. So it's supposed to be 95.28. Is that okay, everybody?
Yes, sir. It's okay, sir.
Okay, so we have reached the last question, but we still have like 12 minutes. If you have any special question you want us to answer among all of them, apart from the one we have answered, so let me know so we can go back to that.